Welcome to lesson 1.2b. We are going to look at similar triangles now. With triangles, there are three specific checks that you make to see if they are similar. Okay. First one is side, side, side. If all three sides of a triangle are two triangles rather, are proportional, then the triangles are similar. Okay. And the way we compare this, I'm going to use some colors here. Okay. I'm going to color let's start with the shortest side. I'm going to color the shortest side of this one pink, and I'm going to color the shortest side of this one pink. And I'm going to color the longest side blue of each of them. And I think this is yellow. Oh, green. Green will work. Okay, so those are our corresponding sides, okay? The shortest one, the longest one, and the one that's left. Okay, so if I'm looking at this, I'm going to say that side AB is the ratio of the size of AB to the size of XY, which is the corresponding side in the other triangle. That's going to be the same as side BC over side YZ, which is the same as AC over XZ. Okay, I'm going to put in some numbers here. So AB is 4, XY is 5, BC is 6, and YZ is 7.5. AC is 8, and XZ is 10. And if I put those into my calculator and I get a decimal for them, they're all 0.8. So this tells us that the sides are proportional, that the ratio of one to the other are the same, okay? And because these are equal, side, 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 all the sides are proportional to each other, therefore the triangles are similar. Okay, I want to point out, I'm actually just going to color code these because that's fun. There, so that you can see clearly where everything comes from. Okay, but I also need to point out when you're setting up this proportion, it's really important that the numbers on the top of all of the ratios are from one triangle, and the numbers on the bottom are from the other triangle. Okay, you can't mix those up. It has to be consistent, okay? Doesn't matter whether the bigger one's on top or the smaller one's on top. That doesn't matter as long as the bigger one is always in the same place, okay? And the other thing is that if you look at each set of numbers, these are all corresponding sides. Okay, so anytime you do a proportion, things have to be in the right place so that they're connected in some way horizontally and they're connected in a different way vertically. Okay, so in this one we've got all of the top numbers here are from the small triangle, bottom ones are from the big triangle. These are the pink sides, these are the blue sides, these are the green sides. Okay, so side, side, side. If all three sides are proportional, the triangles are similar. Second way is angle, angle. If two angles are the same in both triangles, the triangles are similar. Sometimes this is written as AAA, saying that all three angles are the same, but you only need two of them the same because then the third one is forced to be the same. For example, in this triangle, this angle here is going to be 180 degrees minus 72 plus 35 because I'm taking away those two angles. So this angle is 180 minus 107, which is 73 degrees. So this angle right here is 73 degrees. And over in this triangle, well, these are the same, and they have to add up to 180 degrees, so this has to be 73 degrees as well. Okay, and because of the nature of triangles, if the angles are the same, the sides have to be the same because you can't bend things to make sides not be proportional. Okay, third way is side angle side. And you know what, this one, I just need you to trust me on this one. But what side angle side means is that you've got a side and an angle, and then the next side. So they're in order. So side, angle, side. And then on this one, we've got side and an angle and the side. And those are, well, the angles are the same and the sides are proportional. The triangles have to be similar. Okay. It's a little more complicated to explain that, and you don't really need to know. So let's just leave it at that. Okay. Okay, let's do some examples. This one, the first questions in your assignment are like this, and don't come and ask me how to do it because I'm going to tell you now, okay? It says, name pairs of equal angles and equal ratios of sides in the two similar triangles. So you're told that they're similar. So angle A, what angle does that equal in the other triangle? Well, hopefully you can look at that and you can see that it's angle D. Angle B equals angle E, and angle C equals angle F. Those are both 90-degree angles. Okay, that wasn't hard, was it? And then the equal sides, ratios of sides. So we're going to look for our similar side, our corresponding sides. So C corresponds to F, and B corresponds to E, and D corresponds to A. Okay, but we need to write that up. So we're going to say the ratio of C to F equals the ratio of A to D equals the ratio of B to E. And again, I'm going to point out that this is one triangle. These are all the other triangle. And I'm just going to color my, oops, B to E was the pink one. B to E was the pink one, A to D was the yellow one, and C to F was the blue one. So those are corresponding sides. Okay? Okay, that's all you need to do for the first question or two. Okay. Example 2. Now we're going to actually do some calculations here. Determine the lengths of X and Y. I'm going to color code things again. Okay. So the 2 and the 6 correspond. And here I'm just eyeballing it. I can tell by looking at it that those are the sides that correspond. I can also look at the fact that this side of length 2 is between the angle with 1 tick and the one with 3 ticks. So this is the one between 1 tick and 3 ticks. Those are corresponding sides. Between 2 ticks and 3 ticks corresponds with same thing over there, and between 1 and 2 corresponds. Okay. So I have side length 2 over side length 6 is going to be the same as side length 5 over side length X. Okay, so these are the blue ones, these are the pink ones. And then I can use my cross multiply and divide to solve for X. So X is 6 times 5 divided by 2, which is 15. Does that seem reasonable? Yeah, sure. Okay. And then I'm going to come over here and I'm going to do the calculation for Y. I'm going to use my 2 over 6 again, and that equals 7 over Y. And Y equals 6 times 7 divided by 2. So Y equals 21. Okay. So one thing, now this triangle, you could also just go, just in your head, you go, okay, well, 2 times 3 is 6, so it's going to be 3 times bigger. So x is going to be 3 times 5, which is 15, and y is going to be 7 times 3, which is 21, and that works on this one. But when the numbers are ugly, if you had decimals in there, it wouldn't be as straightforward. This is an easier way to do it that works all the time. Okay. I also wanted to mention something which escapes me now. Okay, if I remember it, I'll come back. Oh, I know what it was. Always, and this is just an always math rule, always use the the numbers that you're given when you can. I could have done this one calculating y, because now I know that x is 15, right? So I could have used 5 over 15 equals 7 over y, and then y equals 15 times 7 divided by 5. I'm going to get the same answer, that y equals 21. But because I used a calculated value right here, if I made an error calculating that one, then my answer for y would be wrong as well. Whereas when I did it with the gray pen, I went back to the original numbers. So if I made an error in the first calculation, it's not going to carry forward. So that's just a habit you should have, okay? Okay, example 3. I like this question. Name pairs of equal angles and equal ratios of sides in the two similar triangles. So again, we're told that these are similar triangles. But where are the two triangles? The thing that is really going to help you with questions like this is redraw the triangles. Notice I'm writing this in capital letters, okay? Oops, can't spell redraw the triangles. This is a be smart about your lazy moment. When you're learning to do this, especially, it'll get easier. But when you're just learning still, redraw the triangles. It helps you see what's happening. Okay. So what I have is I have one small triangle here that has A, B, and F, and I've got a bigger triangle which is the same shape. It's just bigger. And again, within my drawing abilities, which goes from A, C, and D. Okay. Now I'm going to draw the angles in here because that will help us see, because, you know, my drawing abilities. So they all have an angle A, which I'm going to mark with a purple arc. Okay. They all have an angle, this angle B, which I'm going to do with a single tick mark on it. That angle is the same as angle C, and we know that because these lines are parallel. Okay, so I can mark angle B with that symbol, and I mark angle C with that same symbol. And then I'm going to do, in green, I'm going to just do 2 lines for that one, and that angle is the same as D, again, because of the parallel lines. Okay, so angle F here is a 2-stripey, and a D is a 2-stripey. Okay, so now it's easy for me to see that this side corresponds to this side, and this one corresponds to this one, and this one corresponds to this one. So now I need to write it up. Okay, so it's asking me which angles are equal. So I don't need to write that angle A equals angle A because that's really obvious. That's just a given. But the problem I have too is that, what do I mean if I say angle B? Because angle B could be, B is just this point here, right? So angle B could be this angle, or it could be this angle, or it could actually be this whole angle. So it's important, this is a good situation where we could switch to naming our angles with 3 letters. And the way you do that is it's where you start, where you bend, and where you end. So instead of saying angle B, I'm going to say angle ABF, okay? Because that starts at A, goes to B, goes to F, okay? And that equals angle ACD, okay? I could also label that one as angle BCD, because if I start at B and go to C and go to D, that's exactly the same angle as if I start at A and go to C and go to D. Same angle. I would probably go with the ACD because that's how we've drawn it in our second triangle here, but either one is correct. Okay. And then same thing at the other angle, angle AFB equals angle ADC. Or we could call that one FDC. Okay. And our proportional sides. Now this time our sides don't have actual labels, so we need to use the 2 symbols to show the sides. And what we see is that side AB, the ratio of side AB to AC equals AF over AD equals BF over CD. Okay. All right, example 4. This is just another example like in example 3, only we are asked to calculate something this time. And this is where drawing it out is really going to help you, because you can write the numbers you need in the right place on a drawing that matches what it looks like. So I'm going to draw a small triangle here, which has 6 on the bottom and 3 on the side. Okay. And I'm going to draw a slightly bigger version. Oops, that was terrible. Your drawings don't have to be exact, but the closer they are to what the original thing looks like, the better it is for your brain to see what's going on. Okay, it's easier to recognize. I'm gonna actually, as I'm talking, I'm gonna fix this one because that was terrible too. If the more it looks like what it's supposed to look like, the easier it is for you to see relationships, and math is all about the relationships, especially the scale factor stuff. Okay, how long is this bottom line here? Well, if I look over here, this is 4 plus 6, which equals 10. Okay, and I'm telling you, if you don't redraw this, you're going to use 4. Not all the time, but sometimes, and some of you are going to use the 4. So be smart about your lazy and redraw it so that you've got it. It's easy to find the information you need. Okay. All right, corresponding sides, 3 over x corresponds to 6 over 10. X equals 3 times 10. Oops. I hate it when my hand and my mouth don't agree on things. 3 times 10 divided by 6. So x equals 5. Dims. Oops. Dims. Does that make sense? Is 5 a reasonable number for that distance? Yeah, I would say so. I think that's quite reasonable. Okay? All right. Now a really fun one. And I recognize I have a different idea of fun than many of you do. So the first thing I have written down on my notes for this page is, what a mess. How in the heck are you supposed to make sense of that? Well, redraw the triangles. Okay? And I have a tip for you. Be smart about your lazy. Redraw the smallest triangle with the original orientation first. Then rotate it. Okay, that's just one of those things that is going to make life easier for you. So I'm going to start by drawing my big triangle. And this one is super ugly, so I'm going to really try and make it look similar to my original one. Okay, and I'm going to label my points. This is C, this is B, and this is A. And angle A has got a single tick mark in it, like that, okay? And while I'm here, I'm going to label B with a red arc. I'm going to put that up on this drawing here. And I'm going to label C with a green dot, okay? You can label it any way you want, but you can label it different. And some of these notes are going to end up in colors or in black and white, so I want to use so they look different even if they're in black and white. Okay, now I'm going to draw a small version, draw a version of the small triangle, okay? Sorry, I should back up and put some numbers on this. The distance from A to B is 12, and the distance from B to C is x plus 6. All right, now I'm going to draw my smaller triangle up here, and it goes like this. Okay, and this is point E, and this is point D, and this is point C, and point E has the same angle as A actually, and point C is the green dot. Okay, so I know what two of the angles in this triangle are. That means that I know what the third one is, and the third one has to be the red arc. It has to be. It's the only, because the three of them have to add up to 180, right? Okay, so and then I put my distances on. E to C is 6, D to C is 3, and DE is 4. Okay. I find on when it's written like this, it's hard for me to tell which are the corresponding sides. I mean, if I had markers and I could do it with color, I would do that, but you're not always going to have colors. So if you rotate it so that it's the same orientation as ABC, it'll be easier for you to spot accurately which sides correspond to which sides. So when I do this, what I'm actually going to do is I'm going to use this ABC as my model, and I'm just going to draw the same shape smaller. And then I'm going to put mark my angles on it in my colors. Okay, and I know that this is where these angles need to go because it's corresponding to ABC. Oops, it's corresponding to ABC. Okay, and now I'm going to label my points. So I'm going to go, okay, which angle is at the black marker? That's E. So this angle is E. And the red one is D, and the green one is C. And then I can put my distances on that EC is 6, ED is 4, and CD is 3. Well, that was a lot of work just to get a drawing, okay? But now we're all but done. This part's pretty straightforward. My corresponding sides, I'm looking to find what X is. So I need this to be one of my sides, okay? And I need a side where I have both pieces of information, which means I'm using this side, the blue one, right? I have to. That's the only, I don't know how long AC is, so the 6 here is not useful to me. All right, so what I get is that 4 over 12 equals 3 over x plus 6. Okay, that makes sense? Okay, so when I cross multiply and divide this time, remember when you have a fraction line or a divide line, there's invisible brackets there, okay? So what I'm going to do is I'm going to say x plus 6 equals 12 times 3 divided by 4, okay? So x plus 6 equals 36 divided by 4 is 9. And then I'm going to use my magic algebra skills, and I'm going to go minus 6 on this side and minus 6 on this side, and x equals 3. Am I done? No, I have to dims. Does 3 make sense? If I come back to my original drawing and I put a 3 in here instead of the x, is that reasonable? Yeah, it's not 15. 15 would be a problem. But according to my drawing, it looks like it's kind of half of the 6, although the 12 is a bit of a problem. But no, it looks okay. All right, it's reasonable at the very least. Okay, so x equals 3, and we're done. All right, we have just a couple more examples. There are a lot of examples in this, but I want you to have a good set of things that you've seen before you go off and do your work. All right, example 6. Calculate the value of y. Well, we have to find some corresponding angles so we can know which sides are corresponding sides. So you might remember this from grade 4 or something, that when you have two lines that meet in an X, the angles that are across from each other are called vertically opposite. And actually, I finally learned that's because they're opposite sides of the vertex, not because vertical or horizontal, but vertex. They're vertexally opposite. Those are equal, okay? And so now I'm looking at a triangle where I have a black angle and a red angle. So I'm going to make this other one a green angle. And I look at the other triangle, I've got a red angle and a black angle. That means this has to be a green angle. It has to be. There's no other possibility there. Okay? Because they all have to add up to 180. Okay? And then this is, you really need a package of markers for this. It'll make things so much easier. The 5 is going from the red to the green. So that has to correspond to whatever goes from red to green here, which is Y. And the C to B is 6. That's from red to black. And from red to black over here is 10. So now I know what my corresponding sides are. I can write up my proportion. 6 over 10 equals 5 over Y. Pay attention to the triangles, okay? Okay, remember that these two have to be one triangle, and these two have to be the other triangle. Okay, don't be tempted to put 6 and Y the same and 5 and 10 together because those are like top and bottom. Pay attention to the triangle. All right. All right, now we get Y equals 5 times 10 divided by 6, and Y equals 8.3. Does it dims? 8.3? Yep, that seems reasonable to me. Yep. Okay. Okay. One more thing to look at, which is similar properties in right triangles. And the rule is the altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and the original triangle, which just makes my eyes go googly. So let's just not worry about memorizing that rule. You know how I feel about memorizing things that you don't need to. Let's look at this and see if it makes sense, okay? And we'll come back to that afterwards. So we're asked to find the value of Z. So the thing you do need to remember is that I have 3 triangles here, okay? And I am going to draw all 3 of them because that just makes my life so much easier. And I'm going to be smart about my lazy. Okay, so this is the first triangle. There's A, there's B, there's C. C is a right angle. And the distance from A to B is 18 plus 8, which equals 26. Okay, and I'm going to color some of my angles here. So angle A is going to be the red. Okay, and angle B is going to be 2 green lines. All right. All right, now I have another triangle. This one, I could draw them in the same orientation if that's helpful to you. I'm not going to because I can see, well, I've done this before, plus I can see that there's clearly a right angle and there's a short side and a long side and then the hypotenuse, of course. So this one is fairly easy for me to flip in my head. If you can flip it in your head, go ahead. If you can't, draw the triangles in their original orientation, and then flip them, okay? All right, so this small triangle, this is A. So this is A. I'm going to color that one in red. This point here is D, and this point up here is C. But what angle goes up at C? Well, my triangle's got a black and a red, and it needs a green. Do you see how helpful the colors are? Right? Okay. And I've got a small triangle as well, so I'm going to draw a smaller version of this. even smaller. And this small one has the right angle is at D, because of course up here there's a right angle here as well, right? So that's D, and its green angle is B, and this point over here is C, and C must be a red line. It has to be a red angle. This one here has to be red because that's the only way you're going to make the triangle similar, okay? And I was just going to label this one with the green. Okay? All right, so now, oh, we need to put some numbers down on here. So look back at my original drawing. So the distance from B to D is 8. So I'm going to label this B to D as 8. And C to D is Z. So I've got C to D here is Z. And I've actually got C to D in this other triangle is Z. And A to D is 18. A to D is 18. And that's all I know. I don't know what BC is. I don't know what AC is. So BC and AC, I don't know what those are. So I've now got, but that's okay because I've got two corresponding sides where I know the lengths of them. Okay? So my formula or my proportion is going to be, oh, I don't know why it keeps doing that. It's going to be 18 over Z equals Z over 8. Must freak out. I've got Z's in two places. No, you don't need to freak out, okay? Remember, cross multiply and divide is a shortcut for two cross multiplications, okay? What it actually is that Z times Z equals 18 times 8. So Z squared equals 144. And then how do I find what Z equals? Well, I take the square root of Z squared. Remember from our exponents unit, the square root of X squared is X. So I take the square root of Z squared, I take the square root of 144, and I get Z equals 12. Dims. If I go back to my original and I put a 12 in here for my Z, is 12 reasonable? Yeah, it's longer than 8. It's less than 18. Yeah, 12 works. Put a box around it so you know where your answer is. Okay? All right, that's that for section 1.2b. Go do your practice, mark it, do your corrections. Come on back and we'll do section 1.2c on similar polygons.